This video is going to walk us through how to multiply radical expressions. So when we're multiplying radicals, different from yesterday when we were adding and subtracting radicals, in order to add and subtract, both of the numbers underneath the root have to be the same. Whereas when you're multiplying, you're allowed to multiply radicals that are not necessarily like terms. So for example, if I were to multiply 2 square root 3 times 4 square root 5, I can multiply 2 times 4, so multiply the coefficients. That would give me 8, and then I can multiply 3 times 5, and that would give me 15. Okay? From here, we would still need to make sure that we simplify the radical, but the way to multiply a radical is to just multiply them together first and then simplify second. You could also create factor trees first and then multiply, but then you potentially are going to have to do another factor tree. So it's easier to just go ahead and multiply both of the radicals together, get a single radical, and then break it down with a factor tree. So if I multiply these two together, I can multiply the 3 times the negative 2. That would give me negative 6. And then I can multiply the 20 times 5. Now, for the 20 times 5, this is going to be a little bit of a smaller number. 20 times 5 is 100, and that's fine. Then we can just write 100 underneath. We'll look at examples where the numbers are much bigger. When you have bigger numbers, you don't have to necessarily actually multiply them, because your next step is to break this down into a factor tree. So if you're breaking it down anyway, you can always just write down the two numbers that you use to multiply to get whatever your radicand is. So I can multiply 20 times 5 and get 100, and then if I do a factor tree, I could use 20 times 5. Okay, I'm looking for couples, so I can make this 4 times 5, and then that would be one pair. And then 4 is not my single because I can still write two factors from that. That would be another couple. So in this problem, what happens is we actually end up getting no singles, which means that this is a rational number, and my answer should be an integer. It's not going to have a root in it. You might have caught that at the beginning because the square root of 100 is 10. That's a perfect square that we should know. But if you didn't catch it when you do your factor tree, again, you just end up with only couples. So you would multiply 5 times 2 and then times the negative 6 that is already outside of the square root, and that would give me negative 60. And again, that is a rational number. So for our next example, these numbers are a little bit bigger. So it's a multiplication problem. We can go ahead and multiply them. When you see parentheses, that means multiply. So since I have a negative 3 in front of one of my radicals and the other one, there's just a 1 here, then that would equal negative 3. When you're multiplying, you do not multiply the cubes together from the cubed roots. So it would just stay a cubed root, like it just stayed a square root in the last problem. And then I can multiply 100 times 200. Now, some students are going to actually multiply the 100 times 200 and write that big number under here. That's totally fine. But if you do that, that would be 2,000. Then students struggle with, okay, well, what do I break 2,000 down into? Should I just divide by 2? If you divide by 2, it's 1,000, then divide by 2, it's 500, then divide by 2. You're going to be dividing by 2 for a very long time. Okay, so think about, how did you get 2,000? What factors did you multiply to get that value? You multiplied 100 times 20. So technically, I don't really need the number 2,000. What you could have also done is just written 100 times 20 underneath the root, and then broken both of those down. So I can break down 100 into 10 times 10, 5 and 2, 5 and 2. We have to be careful on the multiplication problems because our factor trees are going to be so much larger just by nature because the numbers are bigger. We don't want to lose any of our factors. So at this point, I only have a pair of 2s and a pair of 5s. And if I multiply those together, I'm not going to get 2,000. So I still have a 20 over here that needs to be broken down. This would be 10 and 2, and then another 5 and 2. So I actually end up with 3 5s, and then I also have 3 2s. And then this is a single 2 over here. The 10s do not count because those have been broken down into more prime numbers. So the triples, that family of 2s is going to come out in front, and that group of 5s is going to come out in front. So I would do 2 times 5, which would give me 10, and then times the -3 that's already there. So that would give me -30. And then cubed root of my single, which is just 2. And this would be my final answer. For our last example, this one looks a little bit like it's going to be an addition problem, but because I have the parentheses to start this problem, we're going to start with distribution, which is multiplying. So I'm going to distribute the 4 root 8. I'm going to multiply that both by the square root of 3, and then I'm also going to multiply 4 root 8 times 5. So we just have to be careful here when we're distributing that we remember what our rule is for multiplication. For multiplication, you are allowed to multiply the numbers that are in front of the square root together, and then multiply the numbers that are underneath the square root together. So for this first one, I would do 4 times just 1, which would be 4, and then 8 times 3 is 24. Then when I multiply 4 root 8 times 5, the 4 is in front of the radical and the 5 is just an integer. So I'm allowed to multiply those two together. And then the square root of 8 is just going to stay square root of 8 since it's not being multiplied by anything. So this would be 20 square root of 8. Okay, so that right there is the multiplication piece of this problem. But now it turns into an addition problem, which is what we learned yesterday. So in order to add and subtract radicals together, the number that is underneath the root has to be the same. So I can break down 24, 6 and 4, then 6 would be 3 and 2, and 4 would be 2 and 2. So I have a pair of 2s, a single 2, and a single 3. So the couples are going to come out. I've already got a 4 out in front, so that would make 8. And then the square root of 6. Okay, and then I have to do the same thing for 8. So this would be 4 and 2, 2 and 2. I have a pair of 2s and a single 2. So the couples go out, that would make 40, and then square root of my single, which is just a 2. Now at this point in the problem, if those numbers underneath the radical are the same, then I can combine these together and add them. But because they are different, this would be my final answer.